Hello, everyone, and welcome to AP Calculus AB Unit 3.2, Implicit Differentiation. So, first off, I just want to start with a quick concept tutorial. So, hypothetically, imagine you just had y squared. What you want to do is you're going to be taking the derivative with respect to x. You say d over dx, right? And so, basically what you want to do is you're going to say this is 2y, but then since you're taking the derivative of y, you want to tack on a dy over dx. And you might ask, why am I doing that? Well, because with this y squared, we'll write it over here, you're also going to have d over dy, and then, because you're taking the derivative of y, and then you're going to multiply it by dy over dx. These y's will cancel, and then you'll have d over dx like you started with over here. So that's kind of just the basics. But whenever you take the derivative of y, you're going to tack on a dy over dx. It's kind of the basic thing you have to know. So we'll do this worksheet. We're going to do 3 problems, a basic one, then one with the product rule, and then one just finding the slope after you've found dy dx. And then you should know what to do when you see one of these problems. So first things first, you're going to be multiplying by d over dx. So I'd like to write that to start. So first, x squared, 2x, plus y squared, which is 2y, but then you got to remember you're taking the derivative of y, so that means you're going to need to put on a dy over dx, and that is equal to derivative 9, 0. We'll set this equal, so 2y is equal to negative 2x. We'll divide by 2y, divide by 2y. So dy over dx, sorry, that looks good. Y over dx is equal to negative y over x. Or, sorry, negative x over y. There we go. Okay. Now, this is chain rule, so that's with this one right here, because the x and the y, they multiply together. So first off, we'll multiply, we'll multiply by d over dx. So x cubed goes to 3x squared minus xy, so treat each as an individual term. So you do the derivative of x is 1 times y plus, and remember this minus is going to get distributed to both these terms, plus the derivative of x, which is 1, x times the derivative of y, which is 1, times dy dx, because you're taking that derivative of y, and then plus 2y dy dx is equal to 0, derivative of 7. So we'll just write this out. So we get 3x squared minus y minus x times dy over dx plus 2y dy dx equal to 0. So we'll put the dy dx's on one side and these on the other. So this is going to be y minus 3x squared is equal to negative x dy over dx plus 2y dy over dx. We can factor out the dy over dx to get dy over dx negative x plus 2y is equal to y minus 3x squared. Then we'll divide, so then we just have dy over dx is equal to y minus 3x squared over negative x plus 2y. Oh, shoot. Negative x plus 2y, just like so. Cool. And then, so that's how you do that with the product rule. And then finally, 25. So you can kind of just treat these as two. This is another product rule case, so you treat these as two individual terms. So what we'll do is, just starting off, we'll say the derivative of x squared plus 4, which is 2x times y plus x squared plus 4 times the derivative of y, which is just 1, and then it would be dy over dx, like so. And then, so this would be just 2xy plus x squared plus 4 dy dx. So we'll set this equal, so we'll say negative 2xy is equal to x squared plus 4 dy over dx divided by x squared plus 4 x squared plus 4. So then we know that dy over dx is equal to negative 2xy over x squared plus 4. And then in the equation, it says solve for dy dx. So we know our point is 2 comma 1. So we'll just plug in those values. So we'll say dy over dx is equal to negative 2 times my x value, which is 2, times my y value, which is 1, all over my x value, so 2 squared plus 4. So this will be negative 4 over 8. So my final answer, simplified, dy over dx is equal to negative 1/2. So yeah, that pretty much wraps it up. You take the derivative d over dx to the problem. Every time you take a derivative of y, you're going to put dy dx. And then you just solve it like you're taking any other derivative of an equation, and then you can manipulate it to get your final answer, and then plug in points to find the slope or find the tangent line or whatever other type of question College Board may ask. Perfect. Thank you.